Okay, let's set the scene. Imagine you're out there, maybe pushing a fast sport fisher or commanding a large super yacht, and bam, the world just vanishes. Thick fog rolls in off Maine.
Yeah, zero visibility.
Exactly. Or maybe you're down South Caribbean tracking this really dark, fast squall line barreling down on you across open water.
A familiar situation for many mariners.
Right. So when your own eyes fail, when you can't see a thing, what's the one piece of tech that defines your confidence, your safety, your peace of mind?
It's got to be the radar, no question. It becomes your digital eyes working perfectly when yours don't.
That leads us right into today's deep dive, Furuno Marine Electronics. We've got quite a stack of material here, covering more than 70 years of their work.
A long history.
And our aim today, for you listening, is to really unpack what makes Furuno considered the gold standard in the industry, especially for high-end yachts, professional operations.
Right. And our mission really is to give you a shortcut to understanding that situational awareness they offer. We're going past the usual marketing stuff.
Yeah, we want the facts.
We're focusing on the maybe surprising facts about their core tech, how their systems integrate. This company, it's got this 70-year legacy, right? They went from those early kind of clunky analog systems,
right,
all the way to today's incredibly advanced NavNet TZ Touch 3, and we want to explore how that whole journey translates into safety for you out on the water.
Okay, let's start at the beginning then, the foundation. Precision and reliability. I mean, if you look across marine electronics, there's a lot of competition.
Oh, absolutely.
So why does Furuno seem to consistently hold that top spot, particularly when you're talking pure radar performance? What's their unique engineering insight? What are they doing differently?
Well, what's really fascinating, I think, isn't just that they make good radar today. It's that their reputation, their whole foundation, was built on signal processing tech they developed decades ago. They were pioneers in filtering out proprietary signal noise.
Ah, okay. Which means they're known for that absolute defining characteristic of reliable radar, high-definition target separation.
So it's not just picking up something is out there, but being able to clearly tell, say, a small lobster pot marker from a tiny sailboat or even a wave crest, separating it from the actual clutter, even far off.
Precisely. You get that crystal clear boundary, that level of detail, plus their ability for genuinely long-range detection. It just extends your operational window so much, especially in really bad conditions.
Right.
But the real game changer more recently has been the shift, the move towards solid state and pulse compression radar technology.
Okay, solid state. We hear that term everywhere now in electronics. Can you give us maybe a quick analogy, something high impact for a mariner who might be used to, older radar systems?
Sure. Think of the old magnetron radar, the traditional kind, like an old incandescent light bulb.
Okay.
It needs this high power, high voltage tube. It takes time to warm up before it works properly, and critically, it degrades over time, losing power. Right. I remember that warm-up time.
Exactly. Now, solid state, or pulse compression radar, it's like switching to an LED light. It's instant on. Uses dramatically less power, generates less heat, and it's just inherently more reliable because, fewer moving parts and no high-wear component like that magnetron tube.
Wow, that instant-on capability alone.
Yeah.
That sounds like a massive practical benefit. No waiting around if a squall pops up suddenly.
It really is. And the tech itself, it actively reduces signal noise while boosting the resolution using some pretty complex signal processing. Plus, for offshore use, these solid-state units are built for continuous operation, minimal maintenance.
Okay.
That rugged reliability, it's often overlooked in the flashy features, but it's honestly why so many professional fleets just swear by Furuno.
Okay, so the hardware is like bomb-proof, engineered for precision.
Yeah.
Got it. But all that power is kind of useless if the captain's struggling, hunting through menus just to tweak the game.
Absolutely. User interface is key.
So let's shift to that nerve center, the user experience. Let's talk about the Furuno NavNet family, the multifunction displays, the MFDs.
Right. The NavNet family is actually a perfect example of how the tech has evolved over time. If you look back at their legacy system, the NavNet VX2.
I remember those.
Yeah. Incredibly robust for its day, right? Physical buttons, standard Ethernet connection. Definitely got the job done with CMAP or Navionics charts. But, the interface looks pretty dated now.
So what about their current flagship systems? What's the leap?
That's the NavNet TZ-T2 and now the current TZ Touch 3 series. And the leap, Honestly, it's profound. We went from all those physical buttons to this unified, multi-touch glass bridge feel.
Sweet.
Very. And beyond just Ethernet, the connectivity just exploded. High-speed Wi-Fi, NMEA 2000 integration. And crucially, these are the systems compatible with that instant on-solid-state radar we talked about, the DRS-4D NXT. Plus, they use Furuno's own time-zero raster and vector charting.
Oh, and you mentioned NMEA 2000 there. Just quickly, for anyone listening who might be newer to this, why is that specific standard, NMEA 2000, why does it matter so much?
Good question. NMEA 2000 is basically the standardized communication backbone for all modern marine electronics. Think of it like the USB standard for your computer, but for your boat's instruments, or maybe a high-speed data highway.
Okay.
It lets every sensor, your GPS, depth sounder, radar, even engine data speak the exact same digital language. Without that standard, trying to get different devices to talk to each other is slow, messy, often custom work.
Right, so that standardization makes upgrading, adding components much, much smoother. Which brings us to the display itself. People say the screen is the captain's lifeline, but the reality on a bridge is often harsh sunlight, spray, constant movement. How do these displays actually hold up?
Well, Furuno definitely gets that screen visibility isn't some luxury feature. It's fundamental to safety. The TZ Touch 3 uses these ultra-bright LED screens. You can actually see them clearly, even in direct, harsh midday sun.
That's impressive.
And they use anti-glare, toughened, waterproof glass. But beyond the physical screen, the real operational edge comes from the time-zero interface itself.
The system that redraws charts instantly, is that right?
Yes. Instant zooming, instant panning. Imagine you're trying to quickly get your bearings in a crowded channel, right? You cannot afford to wait 5, maybe 10 seconds for the chart to redraw and catch up when you zoom in.
No way, too slow.
Time zero just eliminates that lag completely. That's speed. It's paramount. And it significantly cuts down the cognitive load, the mental effort for the person at the helm during stressful maneuvers. It's literally the difference between reacting instantly and reacting, 10 seconds too late.
And time is distance when you're moving on the water. Latency is dangerous. Okay, that makes perfect sense. Let's move on then. Matching technology to mission. Because, as we know, one size definitely doesn't fit all in boating.
Absolutely not.
And here's where it gets, I think, really interesting. How does Furuno actually segment its radar models? How do they match the tech to, say, a 40-foot sport fisher versus a massive 150-foot super yacht?
They do a really good job aligning the technology with the vessel size and, crucially, its operational range needs. For your typical coastal cruiser or sport fishing boat, you've got what you could call the compact power category. And that's perfectly represented by the Furuno DRS-4D NXT.
Okay, the NXT. That's the solid-state Doppler system we were just discussing.
Well, it's the one. Solid-state, Doppler built-in.
So what are the unique functional advantages of that NXT that, say, a serious angler or performance sailor would really care about?
Intelligence and speed, basically. The NXT has a feature called Target Analyzer. And this isn't just marketing fluff, it's genuinely useful. It automatically color codes potential collision threats based on their movement relative to you.
How does that work?
Targets moving towards your boat are highlighted in red. Things that are stationary or moving away show up green. It's like an instant visual threat assessment.
Wow, okay. It simplifies things quickly.
It really does. Plus, you get that fast 24 or 36 RPM antenna rotation for quick updates. And of course, the instant-on readiness, so it's incredibly responsive.
Okay, so that's the agile, kind of high-tech, smart package for smaller to mid-sized boats. But what about the big players? The super yachts, the commercial vessels, where extreme range and maybe regulatory compliance are the top priorities?
Right. That's where you enter the domain of the Furuno FR12 radar system. This system, it's the successor to their legendary, really reliable 2115 model. The FR12 is all about extended range and absolute precision. We're talking detection capabilities out to 96 nautical miles.
96 nautical miles. That's phenomenal reach. But hang on, if the solid-state DRS-4D NXT is so advanced, so efficient, why would a commercial captain or a super yacht owner choose the sort of traditional pulse technology successor like the FR12? Doesn't that seem like a step back from solid-state?
That's a really crucial critical point. And the answer is nuanced. The big push is towards solid state for most recreational and coastal applications because of all those benefits we discussed.
Right.
But traditional pulse radar, using a magnetron, still generally dominates at the extreme long-range end of the spectrum. So while the FR-12 uses very modern signal processing, it often still relies on that high-power magnetron pulse technology to achieve that staggering 96-mile range. Solid-state systems typically just can't reach quite that far yet. It's the highest power output, longest reach system they offer.
I see. So it's a trade-off, a calculation of cost, power consumption, versus needing that absolute maximum detection distance.
Exactly. And for those commercial applications, the FR-12 also brings in ARPA target tracking automatic radar plotting aid. It can track up to 100 different targets simultaneously. That's essential for navigating dense shipping lanes safely.
Okay, so you get that full commercial level bridge awareness, but still integrated within that slick NavNet TZ Touch ecosystem we talked about earlier.
Precisely. It all ties together.
Which actually brings us perfectly to the ecosystem itself. Because the real strength isn't just one great radar dome or one great screen, right? It's the network. That's where Furuno delivers that true, complete situational awareness.
Absolutely. You only unlock the full power of the system when you integrate everything together using those NAME A2000 and Ethernet networks we mentioned. That's what transforms the bridge from just a collection of different screens into a truly intelligent command center.
So break down the scope of this integration for us. What all connects?
Well, it starts with the basics, like a seamless link between the radar, the autopilot, and the GPS for automated steering and navigation. Then you add mandatory safety layers integration with AIS, the automatic identification system.
Right, so you see all the big ships and yachts nearby. Identify.
Exactly. And for more specialized missions like serious fishing or exploration, it integrates deeply with sonar systems, especially the newer HRP fish finding technology for incredible detail below the boat.
Okay, and thinking bigger picture, modern yachting. How have external technologies, things outside the traditional marine electronics sphere, changed the game here?
That ability to integrate external systems is, well, it's paramount now. A huge example is modern connectivity, like fully incorporating Starlink Maritime Internet.
Ah, the satellite internet.
Right. This lets you pull down real-time chart updates, detailed weather JUR files directly into the NavNet system, even when you're way offshore. The system has to be able to grab data from a global network now, not just its own local sensors.
That really changes things. You mentioned a case study earlier, I think, a 120-foot yacht upgrade. That sounds like a good example of the real-world impact of this integration. What happened when they moved away from an older Furuno system?
Yeah, it was a great example. The captain reported their old system, an aging Furuno 2115, was causing noticeable delays in target refresh. You'd see targets jump instead of smoothly tracking. And worse, they were getting intermittent range loss.
Not good.
Definitely not. So when they upgraded the radar itself to the FR-12 and synced it all up with a new NavNet TZT2 display network, using that high-speed NMEA 2000 and Ethernet backbone, the results were immediate and dramatic. They measured a 40% faster target refresh rate.
40% faster.
Yes, and a 30% improvement in reliable detection range.
Wow. That 40% faster refresh, that's not just some number on a spec sheet. That's a real operational advantage when you're trying to maneuver a huge vessel in tight quarters.
It absolutely is. And the crucial implication, the captain stressed, was the huge reduction in his cognitive load, basically. Less mental stress during complex, high-traffic situations. The system was doing more work, synthesizing the data faster, presenting it more clearly.
Makes sense.
Furthermore, because it's designed as a robust ecosystem, if one display were to fail, the network architecture allows key functions to be instantly shifted to a backup display. Critical nav data is never lost. That resilience is a big part of the integrated value proposition.
Okay, one final but really essential point before we kind of wrap up the ecosystem discussion.
Yeah.
We've talked a lot about the quality of the hardware, the smarts of the software, but none of this works right if the initial installation is botched, right?
Oh, it absolutely cannot be overstated. The need for professional NMEA certified installation is, well, it's absolute. You can have the best gear in the world, but improper physical setup, things like poor antenna placement creating blind spots, incorrect cable routing causing interference, faulty calibration, it can lead to distorted readings, bad performance.
Or worse.
Or worse, dangerous blind zones that completely defeat the purpose of having the radar in the first place. This hardware requires specialized expertise to integrate properly. It's not plug and play.
Right. Critical point. Okay, so let's try and synthesize this. What does this all mean for you, the person listening? What's the single biggest takeaway from this deep dive?
I think it's this. Choosing Furuno isn't just buying a radar or a chart plotter. You're investing in a unified command experience. And that experience is built on, really, three tellers. That deep-rooted engineering reliability we talked about first.
Yeah.
Then the advanced technology, whether it's solid state or pulse compression, depending on the need. And finally, that seamless integration through the NavNet TZ Touch 3 platform. The ultimate value isn't really the screen or the radar dome alone. It's the fact that all these systems, nav, radar, GPS, sonar, AIS, are communicating intelligently at high speed, sharing data, making the whole greater than the sum of its parts.
And it's not just Furuno talking to Furuno, right? You mentioned they play well with others, too.
That's right. While the core strength lies in the complete Furuno system, the architecture has flexibility built in. You can maintain multi-brand compatibility if needed, maybe integrate with specific instruments from Garmin or Raymarine for a niche purpose, or, increasingly common on large yachts, integrate the navigation data with high-end AV and automation systems like Crestron Marine for total vessel command from different interfaces. It's designed to be an open, intelligent bridge.
That blending. High-end navigation, complex radar, and these almost residential-style automation systems, all driven by global internet like Starlink.
Yeah.
That really feels like the definition of the modern yacht bridge.
It really does.
We've seen how today's tech allows this powerful, almost commercial-grade radar to be networked with basically every other system on board.
Indeed. It's moved so far beyond just plotting your position on a chart.
Okay, so here's a final, maybe provocative thought for you, our listener, to chew on. If the yacht's bridge is no longer just a collection of standalone instruments, but instead this fully integrated, highly automated digital command center, all driven by high-speed networks and incredibly complex software, does the fundamental skill set required to be a modern captain need to shift too?
An interesting question.
Are we moving away from the captain as purely an expert navigator, reading a compass, interpreting paper charts, toward the captain needing to be a highly sophisticated integrated systems manager, someone who understands the network as much as the sea state? Something to consider the next time you're looking out at that horizon.
A fascinating challenge and a reality, I think, for every professional mariner today.